Just be aware, we are recording this. And I don't know if you guys knew this, but we do, Mike here takes our videos and publish them to YouTube. So we are spreading the knowledge all over the place. So that is your warning that this meeting is being recorded. Please, no crude language.
Okay, reason you're all here. Again, welcome, and welcome Marissa Loftus. Okay. I made that mistake earlier, sorry. She's agreed to give a talk as given on the title screen here, and we're looking forward to that. Marissa recently graduated from Kutztown with a BS in geology and a minor in environmental geography. She's been working since her graduation at Eurofins, the lab that we all used to call Lancaster Labs, and plans to attend graduate school for sedimentary geochemistry. She's a caver. She likes going underground, I guess.
I don't know if you could.
She likes the carbonates. Prior to going to Kutztown, she had a variety of experiences working in the vicinity of Pittston, Pennsylvania, doing, I guess, customer service, working at places where, you know, irate people would call and she'd have to calm them down. She worked at the Geek Squad, according to the creeping I did on the internet on her. She got some pretty good kudos in her, I guess it's hopefully Eurofins, because they say you're highly motivated and astute. And we're pretty proud to hear your talk on carbonate rocks up there in Lycoming County. Thank you.
All right, so thank you so much. Yeah, I am really excited to tell you guys about these weird Silurian carbonates. So we're looking at this through the lens of karst. Specifically, we're using a cave to go through and look at it in different stratigraphic levels, which I think is pretty cool. We're also looking at the kind of carbonate facies, so as it's changing through. We're adjusting something. Okay. All right. So just a little bit about me. So like Kent said, I was a caver before I was a geologist, and that's kind of how I got the opportunity to start this research project. Back in the early days of the pandemic, so in 2020, I received an email from a landowner. At the time, I was the chairperson for Bald Eagle Grotto. So this landowner reached out to me and he said that he had a large unexplored cavern on his property in Lycoming County. He also said that the cavern had been undiscovered, but he knew it was there. So just to zoom in on the area that we're looking at, anybody who's kind of familiar with the structure of the area, this is the Nippenose anticline. So we're not actually in the anticline. We're on the north limb of it, right up there. So we're along that west, the branch of the west branch of the Susquehanna. It's a weird area for caves. There aren't really any that are documented in this area. So when we got to the property, it didn't really initially look too promising. The landowner had he kind of was basing his belief of the cave off of a few things. He did have some karst on the property, but he also had read this historical document, which I finally found that actually earlier this week. I was very excited about that. This is a snippet from it. It's the silver mining Native Americans. Ogdenbaugh Gap is right on their property. The landowner read this and he did actually believe it because there are a couple of reports of a cave on that property. Now, some of the reports say that this cave was very big and people would actually go there to get water from the springs that were there. There are quite a few springs on the property as well. I think that if there was a historical cave on the property, though, it was probably destroyed when they put the railroad in, which I have a picture that's going to be a little bit more zoomed in. The remaining caves on the property, spoilers, there are caves on the property. The remaining caves, though, are really close to the railroad. If you've ever seen pictures of how they got the railroad in, it was a lot of dynamite. So any big cave, probably gone. So when we got there, we saw these two little small karst features. The one on the left, we call the Porcupine Cave. You probably guess why. Those are all quills. This is not a person-sized cave. There is no way for us to get in there. The one on the right was a little bit bigger. That goes for about 20 feet into a flowstone crawlway, which flowstone is just calcite that's been kind of like globular masses. So that was promising at least. We know that there is limestone on the property. Just to kind of map this out for you guys, there's that first one, and then there's that second one. So those are both at about 600 feet. And you can see the railroad is very, very close to there. While we were there, we did see another little bit of limestone. This one actually looked much more promising than the other one. It was a little bit farther up the mountain, so a little bit farther to the south. And this limestone head wall was about 2 or 3 feet of limestone exposed. Interestingly enough, you could see the sinkhole that it's located in on LiDAR, just to kind of highlight it. And this picture I just included just to show that we are in a little closed depression there. I promise she actually did not throw the mud at anybody there. So that sinkhole apparently only opened up within the last 20 years. And I only know that because another caver / geologist who was in the grotto went out to the same property about 20 years ago, looked at it and said the geology is all wrong. There is not anything promising here as far as caves, but that sinkhole also apparently was not there. And the sinkhole did have a little stream that was kind of draining into this kind of nebulous little hole. We weren't sure where the stream was going. So just map that out. There's that third one. So it's kind of in line with the Porcupine Cave. Not that far apart. There's only maybe 100 to 200 feet at most between them. So this is the geologic map of the area. So when the caver who went out there previously looked at it and said the geology is all wrong, he's not completely incorrect. If you look at where we would have been, we're kind of right along that thrust fault there. And that is mapped as the Rose Hill. Obviously, more than likely, it's just a little bit misaligned. Unfortunately, there's not a lot of good outcrop exposure here. So just to do a quick little overview, for anybody who needs a reminder of those weird Silurian rocks, we have the Tuscarora, which pretty much everybody is familiar with. That's our nice sandstone. We have the Rose Hill, a lot of shales, clay stones, some mudstones, little interbedded sandstones. And then where the cave is most likely, it's the Mifflintown Formation. If you notice, they do say in the description that there's a little coral and patch reef, which even though we haven't quite gotten to that point yet, and I did not get to that point where I was considering a reef instead of a cave for a while, about a year of the project, that does kind of become important later. So this is just a detailed look at the stratigraphy of the area. So we have the Rose Hill Formation, and then it goes to the Rochester Shale and the McKenzie, which both of those are in the Mifflintown Formation. Here's another mention to just a little patch reef in the Mifflintown. This one is from the geology of Pennsylvania, which I'm sure a lot of you are familiar with, but that's where they talk about that other little bioherm in the Mifflintown. So since our exposure as far as outcrops were so incredibly poor here, there was a little bit of superficial mapping done that we wound up doing. So we have, the Tuscarora. This is kind of like right at that transition. This is actually Rosanna's picture, not mine. We have a big old Rose Hill shale pile. This is a weird little landslide type of area. The landowner was actually using it to mine out shale for things at some point in time. And then down here, we did have a little bit of evidence of that faulting. We have some little slicken lines here, and I have seen on this side some slicken sides. Unfortunately, that block was not in place, so we can't really necessarily use it for anything terribly useful, but that wasn't an area that the landowner was trying to dig out the cave, so it was probably dislodged from something in that area. So just to jump back to our geologic map, one more tool that we used to determine where we were as far as formations was fossils. Especially in the Tuscarora, there were not any good outcrops, but we were seeing just big blocks that tumbled down of some nice arthrophycus. That we did carry that rock out, and it was a bad time. Nobody enjoyed that. From the Rose Hill Shale pile, we have some nice little ostracods, a couple of other little things there too. And then this is actually in one of those smaller caves, and this is a little coral. So this is where kind of the patch reef starts to become relevant, and you can see that this was definitely a beach type of environment near shore marine, which if you look at what the Silurian was doing during this time, here's another picture from that same book, that same publication. There was a little shallow sea in Pennsylvania during that time. This was the basin. That basin did migrate episodically throughout the Silurian, and the Silurian was kind of a chaotic time as far as climate. Just another little picture of what the Silurian was doing. So you can see right through here, we have that keel line, so that's where that basin would have been oriented. Again, it would have migrated, but then towards the late Silurian, it started moving a little bit more towards the Great Lakes region. So that's where we had a lot of those really good reef development going on. And the ones that we have in Pennsylvania, because we do, of course, have more than one tiny patch reef in Pennsylvania, would have been little eastern outliers to that. So these are the reefs that I've been able to track down any documentation for in Pennsylvania. We have the 1-year Lock Haven. So that's actually part of the reef pore from that outcrop. Of course, we have the cave/reef, which I've been kind of calling the Jersey Shore Reef just for my own reef reference. We do have documentation of another one in Allenwood, which I believe Inners was documenting. I was not able to get to that one to take a look at it. I'm not really sure if the outcrop is even there anymore. I will say that the 1-year Lock Haven isn't much of an outcrop anymore. It's just kind of all crumbly blobs of stone. So if you look though at the kind of ridge lines, actually I'm just going to flip back one just to show you. You can see that ridge of the Tuscarora. And if you follow, they're all pretty much at the same horizon. So they're all occurring mostly at that boundary between the Rochester Shale going into the McKenzie limestone. All right, so we have kind of our little setup for what was going on. So now we'll get into the fun cave pictures. So this picture is a little bit of a spoiler for how far we had to dig down. If you remember me saying that the initial head wall was about 2 feet. This is about 6 feet of head wall at this point. But we started digging in May of 2020. We started digging on that upper limestone head wall. So that one right down there. Here's a picture of the sinkhole as we were starting to dig out the cave. We picked that spot just because that was where the water was going. The caves at the lower, the lower caves, the 2 smaller ones, would have required a lot more work than this was. For the most part, these were just large sandstone blocks, nothing too terrible to pull out. There were a few of them that were very big, and thankfully, the landowner was very helpful in all of this, and he actually used some of his machinery to get some of that out. We also had somebody that we call Rex, and Rex was able to kind of just heft them out of there. We had to yell at him like, no, use the machine. So this is just a picture of the limestone head wall and the progress that we were slowly making. So we're going from about 2 feet exposed to 3, 4, 5, and probably about 6 or 7 feet. That little tiny little calcite stripe right up there was that original picture. It didn't actually take us a very long time. We were very motivated, so it took us maybe a few months to get into the cave. This is what we ultimately wound up with, though. And this really shows the dip of the beds quite nicely, I think. The north is kind of towards me, so I'll kind of dip into the north there. You can see some karst development on the left-hand side and also some on the right-hand side. That was ultimately decided that it wasn't worth exploring. All of this loose soil up here was a real hazard. There was also consistently water pouring down there. The entrance was actually a stream for most of the year. There would be a few months in the summer that it would dry up, but this stream does not seem to well, it's actually a spring and it's where the landowners get their water from. But it doesn't really seem to run dry very often, which is unfortunate for the cavers, but fortunate for everything else. Yeah. So we got into the cave in July of 2020. Again, not a long time. This is what the entrance entailed getting into. You would have to kind of slide down on your back. It was in loose cobbles that had just been kind of swept in. Coming up was always a little bit of a pain. You would just be kind of crawling your way forward and the rocks would be slipping out from underneath you. That's actually one of the landowners coming out of the cave. Right after that opening was another unpleasant part of the cave. So it was great that we got into the cave, but there were still a lot of problems. We do have a short video. Hopefully it'll play okay for the people online. But just to show you. Is it gonna play? Maybe it won't. Well, it was a picture of me going through this crawlway. Unfortunately, it does not seem to be working. Don't worry, we have pictures as well. So this is what would happen to the entrance in the winter, though. All of that would become one giant icy slip hazard. And of course, when the snow would melt, the entrance would start to flood. There was a small crawlway just after that entranceway that would slowly start accumulating mud on the ceiling. So every time that you would go in afterwards, it would be progressively smaller. For everybody who's claustrophobic, this is probably the picture that I was warning you about coming up. So this is what the entrance looked at certain points in time. You would go on your back and just kind of stay really close to the ceiling so that you could breathe. It's not a long crawlway, if that's of any comfort for anybody. You know, you would be popping right through the other side. Worst case scenario, we would just push your head farther in and you'd be through it. You'd be okay. But it really kind of was unpleasant during the winter. You know, the water is coming right from outside. It's freezing cold. So we figured out that we needed to get another entrance. It got to the point that I couldn't get anybody to go into the cave with me. Everyone was like, nope, we are going to wait until spring. But I did not want to wait until spring, so we used something that's called a cave radio. This is kind of it's almost kind of like a geophysics type of thing. It's just a low frequency radio signal that has this part of it that I guess is the transceiver and then the responder, I'm guessing, maybe vice versa. But the way it works is you just have to keep it perfectly level in the cave, and the person on the surface will basically walk in lines to figure out your position. Then you can actually tie it in to a surface survey, so you're able to tell exactly where you are. And it worked fantastically. We wound up digging another entrance. The spot that Doug, who was on the previous slide, spot that Doug told us to dig at was perfect for where we wanted to pop into the cave. So we wound up digging this one open. The landowner again helped us with some of his power equipment. Again, very motivated. Maybe Native American silver mine legends helped with that, but he did truly want to get into the cave as well. So the cool thing about this is we were able to actually take the landowners into the cave at that point, which they really appreciated. This is one of the landowners there and her granddaughter. However, we mostly took them to the pleasant parts of the cave. Even though we had solved the entrance problem at this point, the cave itself was still pretty unpleasant. So this is what you'll typically find in this cave, which I just realized I have not mentioned the name of the cave. I always like to preface it with, I did not name the cave, the landowners did. It is called Double Fantasy Cave. So DFC is typically what we will shorten it to. So this is what you'll find though. A lot of just very muddy, tight, small passages. This is that entrance crawlway that I had the video of that didn't play. But this is where, you know, it's about an 8-inch squeeze. So I would typically go in one side and we'd be hammering at it on both sides, trying to get in. You'll see these large cobbles in a lot of parts of the cave. All of those seem to have washed in from somewhere farther upslope of the cave. So there would have been other entrances into the cave at some point in time. A lot of times, this is what you would wind up looking like after being in the cave. Not all bad. There were a few spots that you could stand though. This is pretty much all of those spots. probably about 3 passages in the whole cave that you can stand up in. It is interesting though, you can see here, you really get a nice look at the stratigraphy in the cave and the different changes as it's going through there. So actually I have one more picture of that. You can see maybe these kind of little beds of impure limestone, maybe little shale interbeds. But most of the cave is like that. And there are some spots that you could actually see where some like folding occurred, even secondary. We also had quite a few formations. This up here is very interesting to me. This is a lot of those cobbles that I mentioned from before. So this is at one section of the cave that's it's pretty high up, I say, but it's still underground. But it's fairly close to the surface. So we believe that there's probably another sinkhole that has been slowly filled in over the past, 1,000 years, most likely. And this is where the patch reef starts being relevant again. So the cave is very fossiliferous. That's one of the things that we noticed almost immediately. There are tons of fossils, but not a ton of fossil diversity. There's a lot of tabulate corals, and later on I have some thin section pictures, which you'll see, but it's pretty much all the same 3 things. This is just a map of the cave to show you what we wound up getting. We wound up with 1,800 feet of cave, which is pretty good for Pennsylvania. It's the longest documented in Lycoming County. It's about 117 feet deep. So that actually matches up pretty closely to the depth of the McKenzie. So it works pretty well with that. This entire thing obviously is not a reef, but there are a few little patches in there as we go through. What's interesting with this map too is you can really see it's following strike for a lot of it. And then these little individual connecting passages are following the dip of the cave. So that kind of tells us that there was faulting in the area. It's very joint controlled. So this is just a profile from the west. And the reason why I'm showing you this is because the way that the reef would have been oriented, it would be a little bit easier to look at it from the west versus from the north or the south. And that's just because of where that long edge of the basin was oriented. So north would be to your left, then south. So you can see again, all the passages are dipping down that way. So for some reason, I decided that doing research in this cave would be a fun thing to do, a heck of a field site. So I made 24 thin sections by hand grinding every single one out. But because I had that map, I was able to locate exactly where I took those thin sections from. After that, we wound up using Dunham's classification of rocks, just because we were looking mostly at the energy of the environment, since that's going to really tell us the most as far as what was going on with the reef at that point in time. So I'm going to go through the different thin sections that we have. A couple of them are pretty interesting looking. So we have our mudstones first off. So quite a few mudstones. These are just the sample numbers. So as I go through, there's a little sample, or I'm sorry, a little map of the cave in the upper right-hand corner. You can see where they came from. I could be convinced that some of these are actually microbial bindstones. I could very easily be convinced of that, but I'm not necessarily sure that would hugely change the depositional environment of it. But we'll go through them. So these are our first ones. So these are in the very back edge of the cave, which just a fun little piece of information about that. From this point, it takes an hour and a half to get out of the cave. So every time I was taking samples out, I was putting them in my bag and then carrying them out of the cave for an hour and a half. People were not very happy with me. So there is also some thought to be put into whether these are microbial or whether they're desiccation features. So kind of the distinction that I would make between them is just that desiccation features will most likely hug the shape of the grains a little bit more, or the shape of the little micrite blobs in there, whereas something microbial would have larger fenestral fabric. So this is one I would maybe actually even say is a microbial bindstone. It is kind of hard to say though. So we have another mudstone. I promise the rest of them are a little bit more exciting than the mudstones. We're starting at the less exciting ones. So we'll keep on going. This one is very interesting. It is laminated. So whether this is something microbial, I don't necessarily think so, just because it doesn't necessarily have any sort of fabric that I can see. As far as like different little growth patterns, it seems that they're just layers of micrite, then maybe tiny little pelloids, then micrite, then pelloids, and that keeps on going for the entire sample. Here's another one. These ones may again also be a grainstone, but what's interesting about this sample are the radial ooids. So ooids are pretty cool. You can tell a lot of different things from them. Radial ooids specifically seem to form in near shore, maybe almost like subaerial, or I'm sorry, aerial environments, ones that would have desiccation cracks. They also tend to form in like hypersaline environments. So this is another one that, again, I could be argued with that this could be microbial. So not a huge ton of diversity there as far as the mudstones. And they're actually not our largest category as far as different rocks that we have in the cave. Next up, we have our wacky stones. So again, a lot more of those radial ooids. So still kind of a very close to shore type of environment. And this is where we start getting some fossils. We start getting some, what I believe is a gastropod, just in a very weird angle. Little pelloids. Then we start getting a little more interesting. So we have most likely a bryozoan here. I believe these are, again, gastropods. For a while, I was kind of going back and forth between if they were burrows of some sort versus gastropods. But if you look, you can see some of the small spirals there. Up next are packstones. And also, I will say that it was horrifying to be making these thin sections and realize just how many dead little sea critters there were around you as you're crawling through the cave. Not great, but a lot more gastropods start showing up here. What I think is interesting with these is you can actually tell how far away from the original patch reef they were. This one was most likely pretty close to the patch reef. If you look at any other studies of specifically the Lock Haven reef, they show that some of it maybe tumble down, like from like the reef flanking pores. So that's what I actually suspect some of this is. This tabulate coral is not intact. In the larger picture of it, you can see that it's just a fragment of a tabulate coral. But there's a little microbial crust around it, and off on the side, again, we have some little gastropods. So another bryozoan here, maybe some shell fragments. You again have more gastropods. So these are probably the best rocks in the cave. The grainstones in this cave have a huge diversity, not of fossils, but of different little facies in there. So again, more of those radial ooids. This is most likely an infilled burrow. You can see there's just a bunch of little pelloids in there. This one, which is very chaotic. Thin section itself may be a little bit thick, unfortunately. But this we're identifying as maybe algae, although I have been kind of leaning towards maybe thinking that it could be a bryozoan as well. Again, little shell fragments, a lot of different stuff going on here. Very sparry though. Very nice, clean washed. More gastropods, more shell fragments. Some really weird looking pelloids. This is actually a little interclass of algae. Whether it's green algae or red algae, I can't necessarily say that I could identify algae that well, but it's just a little rip-up class that's in there. In some of these grainstones as well, you can see a definite pattern where it's somewhat like kind of like thickening towards the middle and then thinning back out. So those could potentially be storm-driven. It could be something along those lines. There are a couple of, and unfortunately I don't have a picture of it, but we have different like little shell beds where they're very thick and then going upwards. That was kind of like a thriving community at one point in time. Again, more gastropods. But this one unfortunately has bubbles, which were definitely not in the rock itself. Another tabular coral that's just a rip-up class there. And then this one, which is very interesting and actually does have more layering down towards the bottom. So our bound stones in the cave. So not a ton of them actually. But this is where we start getting into a little bit more of a patch reef type of environment. So these are all very well encrusted together. The entire slide is like this, but they are very small, as you can see. Whether or not there are any in that part of the cave, it's hard to say because everything is covered in mud. It is unfortunately a cave still. This one I would say is a microbial bound stone. You can see distinct layering here as they're kind of encrusting and binding. So a little bit different than the tabular coral bound stone, but serves a similar purpose. The Lock Haven reef does note a stromatolitic cap on top of the reef as it became aerially exposed. I have not seen anything necessarily like that here. So again, we are kind of limited by where the passages can take us is the big kind of problem with trying to make a depositional model based on this. But that's really ultimately something that you'd have to deal with just with limited outcrop exposure as well. We have a lot of outcrop, but not maybe where I would want the outcrop to be in a cave. So these are just a couple more of the tabular corals that we found. So this one was actually on the roof of one of the rooms. So you can see a pretty good head there. This is actually the bottom of it. And then we do have another one right here. We have a picture coming up that shows one that was very close by to this that unfortunately got broken off. Unfortunately, but also fortunate because it's a very, very nice sample. So you can see these two spots here. So this is the one that got broken off as we were moving through the cave. Of course, when you're in a cave, you're trying to be as careful as possible, but that can be very difficult just because, you know, it's a somewhat dangerous environment and maybe you'll suddenly slip and you have to try to catch yourself. You have limited places to step. So really the only types of corals that we see in the Silurian cave, well, yeah, Silurian caves, not there's a ton of them, but in this Silurian cave are just the tabular corals. Facies, I forget the full name of it, but that's really the only specific one that you'll see. So it is interesting looking at the limited fossil diversity of the cave, which we'll get to that in a little bit. So this is another example of some of the fossils that you'll see in the cave. See, the rock is very kind of munched up and gross looking here. It's not necessarily good, clean limestone. A lot of the cave is like that. In fact, actually, most of the cave is like that. You'll be going through and something that you think is a rock is actually just clay. So that takes us to this absolutely ugly looking rock. I'm just gonna take a sip of water quick. You'll see on the top of this, there are actually these little impressions. So can I zoom in? Yeah. So you can probably see those little tiny impressions through there. I am not sure if those are crinoid stems, but I believe that they may be. So there are a few different beds of this rock in the cave. And I'd say I'm using the word rock very loosely here. Here's another one of that same terrible looking rock. When I was doing research with this, we just called it the terrible rock. Unfortunately, the terrible rock is on the floor in the cave. And it's also on the ceiling in some spots. That's fun. Makes me feel safe. So you can see though, it is pretty much just dipping with the rest of the beds. Again, everything's kind of dipping to the north there. Initially, I actually thought that this could be something maybe more recent than the cave, something that was kind of gathering along the passages. Maybe when there'd be a rainstorm, it would bring some mud into it and it was getting plastered along the cave. But as we started actually moving along strike so we could see the dip of the beds, that theory kind of went out the window. So of course, we tried to harvest some of this. Unfortunately, when you hit this rock with a hammer, it just squishes. Just immediately squishes. Thankfully, you can just kind of work it out by hand. So we did take some. One of the theories that we were working on was that maybe this was microbial. It's not microbial. We were thinking, okay, you know, what is this? So this is just under standard binoc scope. So you can see there is kind of a little bit of a graded bed there. You can see there are a lot of different little impressions on it. Some little impressions of fossils. There is another area of the cave that has the same but different weird rock. So some of this was broken off from one of those beds and kind of tumbled along in the stream. But this is still a little bit more of that terrible, terrible rock. It's very soft. You can just hit it and it'll squish. This one's a little bit more consolidated than the other one though. So this first one is in the upper beds of the cave. And then this one is in the lower beds of the cave. So that first one, we actually took and we put it under SEM. So we have little calcite crystals there. And then we have these kind of platey, almost clay-like structures. So there's really not a ton going on in this rock, unfortunately. Every once in a while, you'll see maybe tiny little fragments of shells, but there's nothing very biological in it. We found maybe a few little plant fibers as well, but nothing very significant. So we also recently had some geochemical data done with it, and it seems as if it's quartz and illite. So the illite definitely makes sense. You'll find a lot of illite in the Mifflintown formation. The quartz, I'm still kind of working my acceptance into that because it is weird. But considering where it is with the Rose Hill and the Tuscarora right above it, that does make sense that some of that clastic influx would happen. So that does also help us though with figuring out our overall depositional environment. So we know it's a patch reef, which is great. But it does also help us tell where exactly we were as far as our where we were with us fair weather wave base and with the storm waves. Since that clastic rock obviously was not coming from inside of this little patch reef, because other than that, there's not any clastics in the thin sections. It's just all carbonates. So it helps us know that we are at that fair weather, or I'm sorry, at storm wave base. There would have had to have been some kind of plastic input intermittently that would have caused it to happen. So just to show a couple of the different examples of where we can actually look at our depositional environments using, well, our facies. So that nice bivalve grainstone that we had would most likely be closer to open water, a little bit closer to the edge of that carbonate platform as we were heading out into the basin. Our patch reefs, of course, they're going to be our corals. Our grainstones are kind of interesting in this because depending on what's in the grainstone, you know how close to the margin of the basin they are versus how close they are to the center of the basin. So since we have those radial ooids, which again would say that we are in a very restricted environment, maybe hypersaline, close to shore, since we have those in there, and since it does have an infilled burrow, we could probably say that we're pretty close to any sort of lagoonal, restricted, happy, biological type of area. and also pretty close to shore there. So here's our other grainstone. So this one has a lot more of the gastropods in it. It's also like a little bit less diverse and doesn't have any of those radial ooids. So I personally would say that that probably belongs a little bit farther away from where those radial ooids would be produced and a little bit closer to where we're going to be having the patch reefs and everything. So the pack stones underneath the patch reefs are going to typically have more of the tabulate corals. You might still get some of the gastropods in there. They're kind of like the happy little cockroaches of the sea. They're going to be everywhere, which they really, truly are. And then we do have other pack stones, which since this one has a bryozoan in it, which, you know, kind of a little bit of delicate structure, probably going to be closer to that restricted lagoonal mudstone type environment. So our mudstones, that's where they're going to be coming for the most part. It's a low energy environment. In some cases, though, you will see some more of the wacky stones as well in that environment just for the gastropods. And that's where that wacky stone with the gastropods most likely would have come from. It's still a very low energy environment, but it has a lot of biological activity going on. So other wacky stones, those again are going to be typically past where you're going to be getting a lot of wave activity. It's going to be more protected, but some of it's still going to be carried in. So you can get some of those radial ooids as well. It's going to be a little bit cleaner washed than you would be seeing otherwise. So since I got all this data, wound up plotting it on the cave map. We used a software called Compass. It's a free software that was made by a caver, specifically for cavers to be able to use it more for geologic activity. So this view actually is not that useful, but I'm kind of just putting this here so that you can orient yourself with how it's just stripped down to line plot instead of the cave map. When we use that profile from the west, though, it suddenly starts to be a little bit more useful. So you can see that there is a little bit of a pattern emerging. You can also see those plastic beds. They are definitely distinct beds. Remember that everything through here is at an angle because, you know, we're on the East Coast, so nothing's nice and flat here. When we took the strike and dip of a lot of the beds through here, it was for the most part about 36 degrees dipping to the north. There was one area that was a little bit steeper over here, which that was about 70 degrees. So that's kind of interesting. And considering there is a fault running through there somewhere, I would expect that that probably has something to do with it. Not sure if we're switching between the head wall and the foot wall somehow, and maybe now one of those is going to be steeper than the other. But since everything was so tilted, obviously this still does not give us the full story. When the patch reef was deposited, it wouldn't have been at a 36-degree angle. So this is a little bit of a simplification, but I rotated everything 36 degrees. So you can see there is a little bit of a pattern here. Eventually, I would like to overlay the actual little depositional environment here. You can see at the level where there's a patch reef, so that's the uppermost level there. There is a little restricted mudstone back there. I would love if there were some passages back there. Of course, I'm not going to make more passage because I think the cave is long enough. I don't want to have to take more samples. We have our greenstones just beneath that. You can see again, patch reef, restricted area, wacky stone. Down here it gets a little bit more confusing. So there is one sample area down here where it goes from grainstones to mudstones. So obviously it's moving to a higher environment or higher energy level in the environment, but without really knowing what happens in this area here, that doesn't really tell us that much. As the Silurian was kind of going on, there were some little interglacial periods, so there could have been a lot of different variants as far as sea level. One other thing to kind of like just mention with this is that lack of diversity in fossils. So right before the reef was deposited, there was most likely a minor, very minor extinction event. The Ordovician, which I just learned how to say that the other day, but the Ordovician extinction event. So what it mostly affected was trilobites, conodonts, graptolites, which if you notice in those thin section pictures from before, there aren't any of those. All we have are gastropods and bivalves and corals. Those little, like the shallow carbonate reefs were a little bit less affected than the rest of the, ocean life there, but unfortunately that probably was still part of the reason why we didn't have anything else. So yeah, in summary, so it was in the Wenlock in the Silurian, if anybody's curious about when specifically it was happening. But yeah, our limited diversity. So obviously the depositional model here is just a shallow basin margin. Like I said, it was migrating episodically. Actually, that's one thing I meant to mention here. You could see the patch reef is kind of moving around. Now, were there multiple patch reefs? Probably. But from what I can see, that main largest patch reef does kind of meander throughout the low depositional environment there. So yeah, just some quick acknowledgements. The landowners were really awesome. Like I said, they would always have food for us there. Obviously, Rosanna helped a lot with, just answering questions in general. And the landowners would have lots of questions while we were in the cave, so that was a good thing. Doug helped us out with finding another entrance. And we had a lot of people come help dig, which very grateful to them. And of course, I used a lot of the university resources to make those thin sections. So really grateful for that as well. All right, so any questions?
All right, we'll open it up to questions. Marissa, I'm going to ask you to repeat the question or at least paraphrase it so that way people online can hear the question.
Sure thing.
And those of you online, put your questions into the chat and I will read them for Marissa.
Talked a lot about the mud.
Mm-hmm.
Okay. Did you have any thoughts on where that mud came from? I mean, do you think it could have been recent alluvial mud washed in? Do you think it was residual from the weathering of the limestone? I mean, it's even possible that, given glacial Lake Leslie, possibly, and you're in the area of that impoundment, because some of this could be with custom.
Yeah, so I'm gonna paraphrase.
Yeah, if you can just like, where did the mud come from?
Where the classic mud that we're finding in the cave, the question was about where did that come from? So yeah, I did consider that some of that could be from more modern weathering going on. I don't think that it's from weathering of the carbonate material. There's not really any carbonate in it. I also think that based off of what the geochemistry says that it is, I think that it is most likely from original deposition. I think that the beds are continuous throughout. I don't think that they're just lining the walls of the cave. But yeah.
Was your question about the new mud?
The new mud, yeah, the
The
recent
new mud, not the vents.
Oh, the new mud, the actual new mud. Okay. Yeah, so actually I do think that. I know that we did find, well, Rosanna found a river cobble and we have not found any more of them, but there was just one single river cobble that was like in there though. Like that was, most of what we were pulling out were just big chunks, not really necessarily rounded. So it could be from something along those lines. So yeah, I do think that that is probably more likely from Glacial Lake Leslie. Yeah. Yeah.
So you said when you had initially was exploring the cave, there was like one sinkhole. That kind of indicated that there was a cave there. Can you see, is there evidence of any other like sinkhole or karst features anywhere else along where that cave is?
Yes. So the question was just about whether there were any other sinkholes or karst features. in that area, there absolutely are. If you look, which actually I'm going to have to just flip through. There a way I could just like not flip through everything?
No.
What if I end slideshow?
Yeah, you can do that.
Okay, while I'm pulling it up, I will talk. So with the way that the cave profile is, pretty much every single one of those upper passages, there was a sinkhole above that. All of those are little low areas. Where we wound up digging the new entrance was actually another small sinkhole. So they're all in line with Stripe right there. Yep. Let me see if I can find that. It isn't, because it should be really easy to find. Somewhere. There we go. Yeah, so there's a sinkhole there. There's a sinkhole there. This was the original sinkhole. This was another sinkhole.
We lost your.
You're not seeing.
Oh. Oh, my
laser-
mouse.
laser.
Yep, okay. Thank you. So this was the original entrance. And this is like kind of like looking along Strike. And that's the new entrance. And there was a sinkhole there. And there's a sinkhole over here as well. And actually this passage is where all of those cobble fill is. So there definitely was other entrances at some point in time. Yeah,
Yeah, obviously, a lot of work.
yeah.
Built this cave,
This,
and, just give us a sense of scale from time of, we suspect it's here till the time you pretty much had mapped the cave. How long did that take?
mapped the cave. Ooh,
Yeah.
okay, so the question was just how long until we thought that the cave was there, and then how long until we mapped the cave? So we got into the cave about 2.5 months of after about 2.5 months of digging. So not a long time. However, as far as mapping the cave, it took us until March or May of this year. So about a year to do a whole thing. Only a year, yeah, which is good. It would have been a shorter amount of time if the entrance didn't flood all the time. It's really hard to motivate people to go through that in winter. I tried.
Yeah.
The unusual beds you were talking
Mhm.
about. Those the same ones that have the steeper dip, or were they different?
Different. So the area with the steeper dip is actually right through here. The weird, terrible rock is in this area.
Any possibility these might be some type of flanking beds on the sides of the reef?
I have thought about that because I know that there's supposed to be the like the sandstone like beneath that, and then the mud flats of that. So it could be. I think that the problem is with the data that I have, it's a little bit harder to actually draw that full nice depositional model out. I also haven't necessarily seen as many of the branching corals or vines or framework as other reefs have. So I think it's probably a little bit closer to like the satellite reef that's in Allenwood. It probably may not have that flank, but it definitely could be. Yeah.
Okay, right now we don't have any questions online. For those of you online, if you have a question, put it in the chat. Mike has a question.
With the lack of branching and the low diversity, have you guys given any thought to if, like, from UIDs or other evidence, like if this was fairly shallow or had a high saline gradient, would that also explain some of that you see in the fossil diversity?
Yeah, it's definitely, really all that we could tell from, like I said, the little cockroaches of the sea surviving is just that it was not a happy reef. It wasn't doing great. Whether that was because of that minor mass extinction, which that's kind of a funny thing, like it was not a big deal, just kind of dance. Whether it was from that mass extinction or if it was just from a really terrible environment, which I kind of think it was probably both, especially with those, those classic beds, if that's actually what they are. that would tell me like, okay, what if, it's just kind of wiping out anything that could be there, so it's not gonna necessarily grow up.
Can
Very well.
I follow up with a second? question?
Yeah.
I don't want to take up this time. Was there any evidence for like trace fossils, bioturbation, anything like that?
Not necessarily in the cave. The only really evidence of bioturbation that I would see would be in the thin sections, which maybe some of the mudstones had some small amounts. There were some of those little infilled burrows, and of course, like, yeah, the gastropods, but other than that, not in the cave. No. I would almost maybe argue that that clastic rock had some trace fossils, but I wouldn't necessarily be able to identify them.
Yeah, are there any publicly accessible outcrops or any road cuts up there where you can actually see any of those tabacic coral fossils?
Yes.
Where?
By the Lock Haven one, which actually I think that if there's still some of them left, they do mention that in one of the field trip guides. Was it the 50th, I believe? You might know that. But yeah, there is by Castanea, PA, there's an outcrop. And I would hesitate to call it an outcrop at this point. It's just kind of falling apart, but you could look at the big pieces of rock on the ground. They have the tabular corals. And if you want, you can absolutely take a look at this one. This is from the cave.
Okay, we do have a question from William. Could you quantify or qualify transgressive, regressive due to changes in the rock types you saw?
Tentative, yes. I'm gonna bring that back up. So I'm gonna say tentatively yes, but I think that the Silurian is more complex than just saying that it's a transgressive sequence. I think that there were some periods where sea level very rapidly fell, and then it came back up, and then it rapidly fell, and then it came back up. So I do think that this can be used to say like, okay, maybe we are getting a little bit deeper as we're going through here. But within that, it would be hard to really say like, okay, we're going up, we're going down. So that was kind of a non-answer, but.
Quiet in the chat, so go ahead.
So you said there's other like coral systems in Pennsylvania. So are they from the Silurian as well?
Yes.
Would you expect to see like a similar layout of like fossils and rock types?
Yes, and I keep on forgetting to repeat the question as I've been reminded. Whoops. Yeah, so basically looking at other Silurian reefs and would they have similar rock types? Yeah, those other ones absolutely do have similar rock types. There are some of these in New York as well, but I believe that some of those might actually be a little bit younger than these ones are. I would have to check that. But yeah, for the most part, you're going to see a lot of similarities. The one in Lock Haven seems to have more microbial rocks than I'm seeing, and actually more diversity as far as the different rocks. I also don't really remember any mention of the radial ooids in that one. So.
Well, we are right on time. It is 7:30. So if there's no more questions, thank you.
Yeah.
So I'd like to thank you once again for coming in. This is great. I'm so excited to see so many of you here in person. And those of you online, we encourage you to come join us sometime in the next year. I don't think Ken mentioned, if you saw Amy's email, we have a packed schedule for the next 4 meetings for next year. The fall season, however, is still open. So think of ideas, think of authors, presenters, someone that we can encourage to come up and fill the slate. The another announcement I forgot to mention is we have free publications here. So we laid out the Hags Field Trip Guide books. Help yourself. All right, so that's it. Meeting adjourned, and have happy holidays. See you next year.